Welcome viewers to my platform once again. Today I will be treating indices. I will advise you to subscribe to my platform so that you can benefit from the topics I'll be treating. Okay, indices. The word indices simply means powers. So we can see these numbers there, 2 raised to power 2. This small 2 is called power. This small 3 is called power. So here we have 2 raised to power 2 gives me 2 times 2, that is 4. 2 raised to power 3 means 2 times 2 times 2, that is in 3 places. It gives me 8. Sorry. 2 raised to power 4, that gives me 2 times 2, 4, times 2, 8, times 2, 16. So you can see 16 there. So 2 raised to power 5, that gives me 16 now, the answer, times 2 gives me 32. 2 raised to power 6, that gives me 32 times 2, 64. 2 raised to power 7, that is 64 times 2, 128. Very short. 2 raised to power 8, that is 128 times 2, that gives me 256, and so on and so forth, dot, dot, dot. Right. So in my next slide, I'm going to treat the laws of indices. Now look at these laws of indices. One of the laws is addition law. Now look at how it works. You see, even though you see multiplication in between the two numbers, yet in their powers, that is the index. Indices is a plural word. Index is a singular word. So their index numbers, that is 5 and 3, will be addition. Look at it. Since the base are the same, we add their powers together. That is a raised to power 5 plus 3, which gives me a raised to power 8. I want to check out whether what I said is correct. A raised to power 5, you can see a times a times a times a times a times a raised to power 3. Look at it, a times a times a. So let's work them out. A times a squared times a cubed times this a raised to power 4 times this a raised to power 5 times this a raised to power 6 times this a raised to power 7 times this a raised to power 8, which is what? A raised to power 8. Hence, we now deduce from there that the addition law holds since their two answers are the same. You understand? So when you see multiplication in between two numbers like this, we add their powers. Second law, multiplication law. Now when you see y squared raised to power 3, we multiply their powers together. That is 2 times 3 to give me 6. That is y raised to power 2 times 3, which is y raised to power 6. Let's check. Y raised to power 2 bracket 3. That is y raised to power 2 times y raised to power 2 times y raised to power 2. Okay, so that is going to give me y raised to power 4, y raised to power 2 times y raised to power 2 gives me y raised to power 4. You see, if I decide to expand this, look at it. I can do it this way also. Y raised to power 2 is the same thing as y times another y raised to power 2, y times y, another y again times y times y. That's it. Y times y squared times y1 cubed times this y raised to power 4 times this y raised to power 5 times this y raised to power 6. So you can see that. So we are doing the same thing, right? So now, by this, the multiplication law holds. So when you see numbers like this, y raised to power 2 bracket raised to power 3, multiply their powers and get your answer straight. Now the next law is the zero law. Look at these two numbers, a raised to power 3 divided by a raised to power 3. Any number divided by itself is equal to 1, right? Now, let's look at it. So that gives me a raised to power 3 minus a raised to power 3. That gives me a raised to power 0. Okay? 3 minus 3 is not 0, so that gives me is equal to 1, a raised to power 1. How? Let's check out. I've always told you we are not magicians. So look at it. A raised to power 3 divided by a raised to power 3. That is A raised to power 3 times A raised to power 3 times A raised to power 3 divided, look at that division sign, by this A raised to power 3, A raised to power A times A times A. This A cancel this A, 1, 1. This A cancel this A, 1, 1. This A cancels this A, 1, 1. That gives me 1 times 1 times 1 gives me 1. The numerator all over 1 times 1 times 1, that is 1, the denominator. 1 divided by 1 is equal to 1. Hence, since the two answers are the same, what it means is A raised to power 0, any number raised to power of 0 is equal to 1. It's as simple as that. Look at it. Therefore, any number raised to the power of 0 is equal to 1. That is what it means. This second solution here has justified the first one, right? Now look at the last law I'll be discussing today before I rest my case for today, the negative law. Look at this example. X raised to power 3 minus divided by x raised to power 5, right? So let's solve it by expansion. That is x times x times x divided by x times x times x times x times x. So x cancels x, 1, 1. X times x cancels 1, 1. The third x cancels the third x, 1, 1. I'm left with x times x at the denominator, which is x squared. 1 times 1 times 1 is equal to 1. That gives me 1 all over x raised to power 2. All right, that is by expansion. Now let's look at this by the law of the zero law. Look at this, operating by that, which is the negative indices, right? Look at this. That is x raised to power 3 divided by x raised to power 5. Watch, which gives me x raised to power 3 minus 5. That gives me x raised to power minus 2. This is what we arrive. Now, by the first solution of expansion, we now have 1 all over x squared. And by the second solution, I now have x raised to power minus 2. That means what we see here is the same thing as this. By that, this implies that x raised to power negative, which is minus 2, is equal to 1 all over x raised to power 2. So this justifies the negative law. In other words, once we see any number raised to the power of negative, is the same thing as 1 all over the power of that unknown. Is that okay? So today, this is where we draw our curtain for today. In the next solution, I'm going to be solving some problems. All these are just proofs to back up these laws. So I will be treating some solutions in the subsequent problems. Thank you. God bless you.